So members, let us handle now a wonderful question here, a very nice one. So here they are telling us that a random sample of size 76 of components with resistance this up to this ohms, where when you sum all these ones you get 740, and when you sum their squares you get 8 to 16. Find the unbiased estimate for the random population variance. I think we recall in the statistics that we say if you want the unbiased estimate for the random, for a population variance, you get n over n minus 1. Then we sum the square of those components, we divide them by their number, then minus the mean squared. So when you substitute this is what we get as our variance squared. Remember our x bar, this x bar the mean, we get summation of r over n, and when you do this, this is now our x bar. So this is the unbiased estimate for variance for that population. So now we notice in our calculations, we need the sigma and also need the x bar. So here they're telling us that find the 90% confidence interval. So our 90% is going to be 0.9. So meaning our 2p is 0.9, then our p is going to be 0.45. So then our z alpha over 2 is going to be, I think now people are experts from reading these tables. Mine is 1.645. This is the value I'm reading. So now after they getting that, I think we can now state our formula because we need the interval. Our x bar minus or plus z alpha over 2 sigma over root n. So here our x bar was here 9.7368 plus or minus. Now our sigma is here 3.6710 over root of our n. Our n was 76, and this is 9.7368 plus or minus. Hey, remember this one we are multiplying it with our z alpha. This one over 2, 1.645. So there what we get is 3.671 times 1.645 divided by root. So here the answer I'm getting is 0.6927. So now my upper limit is going to be 368 plus 0.6927, and that will give me 368 plus 0.6927. The answer I am getting is 10.4295. Then my lower limit is going to be, now there we subtract that. So we get 97368 now minus 0.6927. It is going to give me 9.0441. Now my interval is going to be the lower limit 9.0441, then the upper 10.4295. So there my answer will be there. So that's my confidence interval. So it's the interval square brackets. In part number 2, the time a machine takes to print each of the 10 documents were recorded in minutes as below. This, and this. If the time of printing the documents approximately normally distributed with various stats, find the 80% confidence interval over the mean time of printing the documents. So whenever they give us the components, we always get their mean, the mean. So this is where the samples from there. So we get their mean, like adding all of them divided by their number, they were 10. And this is what we get. So now they want the 80% confidence interval. So this is the same as 0.8. So our 2p here is 0.8. So our p will be 0.4. And then our z alpha over 2. We read it down this from the table. P by experts there. My 0.4 there. Okay, let me show you this. You see, we need the p when it's 0.4. P when it's 0.5, I think you see there. The value of z is there. You see, this is z, the value of z is there. 1.282. 1.282. So now, after getting that, we need our variance. I mean, we need our standard deviation. But they gave us that our variance squared is 2.56. And you know that this one is the same as 1.6 squared. So it means that our sigma is 1.6. So now to get our interval, it's very easy. As write it like this, plus or minus z alpha over 2 sigma over root n. Now we have our, which is there, 0.9, then plus or minus our z alpha over 2 is 1.282, then times our standard deviation, 1.6 over root n. From there, see that our n was 10. So 10. So this would be 17.9 plus or minus. When we place that on a calculator, root 10, we place root 10, then 1.6 divided by answer. You press equals, then times 1.282. So the answer we are getting there is 0.6486. So now from there, my upper limit will be 17.9. Or you can, from the next direct from there, you can get it and put it in our confidence in our interval. But for formality, I put it so that people don't get confused. Where did I get what? Then our lower limit, we say we get 7.9. Now we take the minus 0.6486. And the answers we shall get there are so here I'm getting 18.5487, and then for the lower I'll get 17.2513. Now I'm going to pose a question here. I have 17.2513 to 18.5487. Then we cross. Now, I'm going to pose a question. Why do you think that this interval is too small? But I gave that answer already from the previous lesson. Whenever I start, your standard deviation is small, even the interval is going to be small. So it's from 17 to 18. Why? Because this was so small. Or else, if they tell you to comment about the interval, say that the interval is small because the standard deviation affects it. The smaller the standard deviation, the smaller the interval. The bigger this, the bigger the interval. Now we are sure that the mean time of printing these documents is between this and this if they ask for comment. So that will be that. Now, some questions they will give you now statistical data or grouped data, and then they tell you to calculate the variance and then so on. You do those tables, you calculate like we did, you know the formulas. So now there's that one in summation f of x squared over summation f, then minus the mean. So if they give you information terms in the group data, or they give you classes and they tell you now they can bring it in that form. They give you classes and then they tell you to calculate the unbiased estimate of variance, and hence do like we have done here. So be careful. It has been a long day. I think this is our last lesson in normal distribution and so on. See you. We are now going to cover the mighty numerical methods. See you there.